So we're going to start off this video with slope. This is going to be the first in a series of videos that I'm going to film for pre-calculus. And we're going to look at section 1.1 in the textbook, and we're going to go through some basic algebra reviews. So the first thing we're going to look at is slope. So let's talk about slope. Slope is one of the key concepts of algebra when you're talking about lines. And you've seen it before. We've talked about slope, algebra 1, algebra 2, and geometry. So let's just do a little basic review of slope. So the slope is basically the change in y over the change in x. And we see it indicated with an m. And I'm going to use that little delta. That means change, the change in y over the change in x. A lot of you have probably heard rise over run, and that's okay. But slopes don't always rise, and may not always run in the same direction. So rise over run, you have to be kind of cautious using that. So anyway, that's the formula for the slope, or that's the representation. Now, if we want to actually look at the formula for the slope, I'm going to take over here that I have 2 points. I have x1, y1, and it looks like my pen has frozen on me again. x1, y1, and those are not exponents, by the way. Those are subscripts. That's not x squared, this is not y squared. Those are subscripts, which just mean basically that this x is different than this x, and this y is different than this y. A lot of people get that mixed up. So when we look at the actual slope formula itself, the slope formula, to find the change in y from point to point over the change in x from point to point, you have to find a difference. When we want to find out how we change from one value to the next, a lot of times we use a difference or a subtraction. So the slope formula is the difference in the two y values divided by the difference in the two x values. And most of the time you'll see it written y2 minus y1. Sometimes it'll be written as y1 minus y2. If it is, then that means the bottom will be written x1 minus x2. The important thing that you need to know is that the subscripts need to match up. This is a coordinate. x2, y2 is a coordinate. You can see over here. And x1, y1 is a coordinate. So they have to line up vertically. So let me pick two arbitrary random points, and let's calculate a slope. So let's say I have -2, 3, and I have 4, 1. I want to calculate the slope. So I'm going to come back over here, and I'm going to create my slope formula. Now, the way I like to do formulas is I like to rewrite the formula, plug in the division, all of the symbols and operations you're going to use, then go back and plug in the values. That way, for example, in slope, you don't get mixed up with positives and negatives. You make sure that that subtraction is there. If I do have a negative value here, the subtraction is there, and so is the negative. So you have to make sure you don't drop one of those two. So let's look first. Let's look at our y values. I've got 1 and I've got 3. I'm going to do 1 minus 3 on the top. That is my y2 value, and that is my y1 value. Basically, that's the y coordinate for this point, and that's the y coordinate for this point. So then I'm going to plug in my x values. So that is the x coordinate for the first one. That's going to be the second x that we plug in. Again, you have to match up. Notice I have these indicated here. That's x2, that's x1. x1, y1 matches up, and x2, y2 matches up. Can I flip these? You can. But if I put the 3 first and the 1 second, then I would have to put the -2 first and the 4 second to make sure they match up. Remember, we have to have a vertical alignment with our coordinates. So this equals 1 minus 3 is -2. 4 minus -2, that changes to plus a positive, that becomes 6. So you have -2 over 6. Now, I can reduce this. -2/6 can be reduced. 2 goes into both 2 and 6. It's a factor of both. So I can reduce that to -1/3. Therefore, my slope, which I call m, is -1/3. And that is how you calculate the slope of a line. 2 points. So now what we're going to look at is the different types of slopes. And then I'm going to show you the slope actually on the graph and how it applies. But let's get basic. So I'm going to try to scroll here if it allows me to. Okay. So let's look at the different types of slopes. So we have types of slopes. And these should be easily identifiable depending on the direction that the line takes. So I've got types of slopes. The first type of slope is the positive slope. So if we have a positive slope, and I can indicate that with a plus sign, the line will look like this. It's going to go upwards on the graph from left to right. And we usually look at lines from left to right when we're trying to decide if slopes are positive or negative. So that's a positive slope. Think of it as you're climbing up a staircase, which is what the slope actually is. It's like a staircase, and we'll see that in a second. If I have a negative slope, the negative slope will be indicated by a negative sign right there. The negative slope looks like this. That is a line that is actually falling when we go left to right. And I'm going to put the negative there so you can see it, and the positive there so you can see it. So that's how you can see the difference between a negative or a positive sloped line. If you have an equation and you know if the slope is positive or negative, you can tell what direction the line's going to go. By the same token, if you see the line itself and you know what direction it's going, you can determine if the slope is positive or negative. There are, however, two more types of slopes that we can use, or that you will actually see when you are talking about algebraic representations. The next one is called the zero slope. Now look at that letter Z. That is when you have a horizontal line. You do not call it a horizontal slope. It is just indicated when you have a horizontal line. I'm giving you that little memory tool. The Z means 0. If I've got a line that runs horizontally left to right, the slope of that line is 0 because that line is never changing. It's constant. The green, we're increasing left to right. The red, the negative, we're decreasing left to right. The 0, we are not increasing or decreasing. We are at a constant rate of speed or a constant rate of change. The last one that you will see is the one where we have no slope, which you've commonly seen as undefined. And sometimes people will call this an infinite slope, but this is when you have a vertical line like this. There is no slope for a vertical line. The reason there is no slope is, let's think back to what our slope formula was. Let's take a look back. Let's scroll back. So if I go back up here at the top of my document, what is the slope formula represented by? The change in y divided by the change in x. Now, just to make things easier for you, the change in y is our vertical change, right? The up and down change. And the change in x is our horizontal change, left and right. If I'm going up for y, that's positive, and if I'm going to the right for x, that's positive. If I'm going down for y, that's negative, and if I go to the left for x, it's negative. So that's how we determine a slope. This slope right here, negative 1/3, means we're either dropping 1. Let's say we have a point, we're either dropping 1 and going to the right, positive 3, or it means that we are going up 1 and going to the left 3. So that's how you determine your slope. So if I look back, let me get my pointer here. If I look back at the types of slopes here, if you look at this, I've got change in y over change in x, right? This is our typical slope formula. All right. What is the change in x for the 0 line? Well, the change in x is constantly changing going left and right. Y'all see that on the horizontal slope? But is it changing up and down? It's not. So the slope for this guy, it's going to be no change vertically, and then it could be 4, 5, 6, some random number. It's always going to be 0 divided by some number, which is 0. If I apply this to my vertical line down here, then what you're going to see is that the change in x, my left and right, is there a change left and right? No. So the 0 is on the bottom, and then I'll have some random number. It doesn't have to be 7 or 5, guys. It could be 10, 12, 50. No matter what, when it's vertical, I'm going to be dividing by 0. We can't do that. That is why it's not a defined slope. So those are the 4 types of slopes, and that's how you determine a slope using the slope formula. Let's take a quick look at lines on the graph and how we determine slope, and that'll conclude the video. So once again, I want to review. If we go back up top, you can see there's the slope formula right here. The difference in the two y's, the difference in the vertical divided by the distance in the horizontal. So we're going to move along here, and we're going to look at some graphing. So I'm going to add another page. I'm going to add one page, and we're going to do this one same color. Okay, so I'm going to come back up here. We're going to zoom in. Now let's look at the graphing of this. Okay, so when we're graphing, what we're going to see is we'll see a grid, and pardon my art challenged graph. So we've got a graph here. And I've got just a simple, here's your x-axis, and here's your y-axis. Remember, x is always left and right, y is always up and down. X is horizontal, y is vertical. So if I put a line on this graph, and I'm going to go ahead and pick one here. And I'm going to put a set of 3 points, and then I'm going to draw a line through these. Again, don't hate on my art. So there's a line. You should be able to look at this line immediately and determine what kind of slope this line has. The line goes up, left to right. So first thing out of the box, you should be able to tell this is a positive slope. So we've got a positive sloped line, okay? And in fact, to kind of keep in pattern with what we wrote earlier, I think I did the positive in green. So this is a positive line, positive slope, okay? So when we did the slope formula, we came up with the change in y over the change in x. Remember, the slope can be determined with any 2 points on your line. So let's pick these 2 points. If I want to find the slope, I can do it one of 2 ways. I can either find the coordinates of these lines, which will be 3, 2, and notice, the 3 comes first. Over 3, 1, 2, 3, up 2. The coordinates of this point would be 0 because we're not moving left or right, and then 1. So I could plug into my slope formula and do my y2 minus y1 divided by my x2, x1. So I could designate this as x2, y2. It doesn't matter which one is x1, y1, and which one is x2, y2. It doesn't matter. And I could set up my slope formula like so. And we have, I put my minus signs in there. And so my subtraction, so y2 minus y1 and x2 minus x1. And that gives me 2 minus 1 is 1, and 3 minus 0 is 3. So the slope of my line is 1/3. Now, if I were to have chosen this point and this point, or this point and this point, I would have gotten the same thing, 1/3, because you can choose any 2 points on a line and you'll get the same slope. Now, what if I wanted to count the slope from the graph? What does the slope look like on a line? What is a linear slope? Well, when I look at a linear slope, it's like a staircase. So I want to make stairs. I'm going to go here to here, and I'm going to go here to here. And if you did that all the way up, you would see your staircase would create the line. Now, going left to right, what did I do to get from this point to this point? Well, I went up 1, that's positive 1. And I went over 3, that's positive 3. There's my slope, 1/3. Do you see? 1/3, 1/3. If I do this from this point to this point, I will get the same thing. Up 1, that's a positive 1. Over 3, that's a positive 3, 1/3. Now, on the flip side of this, you could go right to left, but you have to go opposite. If you wanted to do your staircase opposite, you could do it this way. But now what am I doing? Down 1, left 3. Do you see why those are negative? I went down 1 and to the left 3. But what happens to a negative and a negative? Positive. Amazing, right? There we go. Same thing. So when you're looking at the graph, you should be able to tell what kind of slope it is. And if it's a graph where the points are actually on whole numbers, you should be able to find the slope. Now, the last thing I'm going to show you in this video, because it's getting kind of long, I don't like my videos to be quite so long, is when we graph other types of lines. So if I have a line here, so here's my 5, my -5. Again, don't be jealous of my artistic ability in drawing coordinate planes. This is your x-axis, this is your y-axis. Let's look at these lines. We know what a positive slope looks like. We just did one. We know the negative slope goes to the left. What about our horizontal line? What did we say about the horizontal line? We said the horizontal line has a slope of 0, right? Why is that? This is a slope of 0 because any point I pick on this line is going to have the same y-coordinate. This guy right here is at 5, 2. This guy is at 2, 2. This guy is at -2, 2. But you can see every y-coordinate is what? 2. So when I do my slope formula and I subtract my 2 y values on the top, what's going to happen? If this guy and this guy are the same, no matter what I have on the bottom, what's going to be on the top? 0. For example, this one, 2 minus 2 is 0. And in the bottom, I have 5 minus 2, which is 3. It doesn't matter. 0 over anything is just 0. That's why horizontal lines have no slope, or sorry, a 0 slope, because there is no vertical change. Now, the vertical line, if I were to draw a vertical line here, for example, now it's not all the y coordinates that are the same, it's all the x coordinates that are the same. This one will be at -5, -3. This guy would be at -5, -1. I could draw another one up here. This guy is going to be at -5, 5. But you'll notice all x's are the same. Now look at your slope formula. What happens when these two guys are the same? You're going to get 0 on the bottom. Can we divide anything by 0? No. That is why the vertical line has no slope. You cannot divide by 0. If you go on Siri and ask it to divide by 0, it'll give you some silly thing with Cookie Monster too. So anyway, that gives you a basic idea of slope, positive, negative, 0, and undefined slope, how to calculate slope on the graph, and how to determine what kind of slope a line has based on the graph.